Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice all your entrance exam question papers because you have these papers along with the detailed PDF solutions available there. Students, for a better preparation, you must download our app. The link is available in the description box. So, today I'll be solving JEE Mains 31 Jan 21, 24, shift 1 paper. This particular video, I'll be solving the mathematical part of the paper. Very best of luck. Let's start with the first question. Here we go. Question number 1 says for a less than b less than c less than 0, let this quadratic function is equal to 0 and alpha is not equal to 1 be one of its root. Then among the following statements, number 1, if alpha belongs to -1 to 0, then b cannot be the GM between a and c. Second, if alpha belongs to 0 and 1, then b may be GM between a and c. So here you have fx. This is given as a plus b minus 2c x square b plus c minus 2a into x c plus a minus 2b. This is your fx. You are particularly given that alpha is not equal to 1. That means maybe 1 is also one of the roots. Let's check. If I put x is equal to 1, what you will get? A plus b minus 2c. Everything is cutting. Okay. This cuts, and this. So that means alpha is 1 root and 1 is the second root. So the two roots are alpha and 1. And you know the product of the roots is given by the constant term divided by the coefficient of x square. So the constant term in this particular one is c plus a minus 2b divided by a plus b minus 2c. The two roots product, that's alpha into 1, which is alpha only, is equal to c plus a minus 2b upon a plus b minus 2c. Now, according to the first statement, if alpha belongs to -1 and 0, this is the first statement. If alpha belongs to this interval -1 and 0. So that means -1 is less than c plus a minus 2b divided by a plus b minus 2c is less than equal to 0. Or you have minus a minus b plus 2c is less than c plus a minus 2b, or c plus a minus 2b is less than 0. This gives me a plus c upon 2 is less than b. Or you will have here C plus B is less than 2A. Okay. Okay. So you have here that B is greater than A plus C upon 2. This is nothing but the arithmetic mean. So that means B can't be GM of A and C because it's greater than already the AM. Okay. AM of A and GM of A and C. So that means your first statement is correct. It says it cannot be. Yes, that's true. Now the second one, alpha belongs to the interval 0, 1. So you have this is the interval of alpha. 0 is less than c plus a minus 2b divided by a plus b minus 2c less than 1. So you have 0 less than c plus a minus 2b, or you have b is less than a plus c upon 2. Also, you have a c plus a minus 2b less than a plus b minus 2c. This will cancel, and you will have here, let's take 3b over here, and here will be 3c. So you have b is greater than c. See here, this is again AM. B is less than AM, therefore B may be the GM. It may be because B is less than the AM. Therefore, B can be the GM between A and C. So the second statement also is correct. That means both are correct and you have the first option as the right answer. Hope you're clear with this. Let's move to the next question, number 2. Question number 2, let A be the sum of coefficient in the expansion of this and B is equal to limit of this. If the equations this and this have a common root where C, D, E are the real numbers, then what is the ratio of D, C and E? Fine. So you're having the expression as 1 minus 2x plus 2x. Before starting with this, I would like to discuss one formula with this. Whenever you have to find out the sum of the coefficients in any expansion, in any expression, then we put x is equal to 1. Why is that? Let's see. You are having 1 plus x raised to power n. This is given as NC0, NC1 into x, and C2 into x square, so on till NCn into x raised to power n. So if I want to find out the sum of the coefficients, I always put x is equal to 1. That gives me 2 power n is equal to, you solve this like this is a whole derivation. This is a different thing. I'm not going to that now. So if you don't know this, mark this thing. If you have to find out the sum of the coefficients, if you are having the expansion as 1 plus minus something, so you will put it as x is equal to 1 and 2 raised to power n. It will be 2 raised to power n then, this expression. So you will have NC0, NC1, NC2, so on till NCn. Okay, so I'll do the same thing in the expansion of this. You are given the expression as 1 minus 2x plus 2 raised to power x, 2 into x square upon power this. I'm repeating 1 minus 2x plus 2x square power 2, 0 to 3 into 3 minus 4x square plus 2x cube power 2, 0 to 4. Let's put x is equal to 1. You will have put x is equal to 1, you will have 1 minus 2 plus 2 power 2023, 3 minus 4 plus 2 power 2024. This is equal to this, which is nothing but 1. So you have the value of A as 1. And now you're given that B is equal to this. Let's write down. You have B is equal to limit x approaching 0, integral 0 to x log 1 plus t divided by t raised to power this dt whole divided by x square. So this is what, if I put x approaching 0, this whole thing, this will actually give me a 0 form. Or maybe not, even though, let's apply the L hospitals rule, it will make the sum doing easier. Because I have to check with this whole thing. Probably it will be 0 Anyways, I'm applying the L hospitals rule because you are having an integral in the in the numerator. So this will make limit x approaching 0. This will be now log 1 because I'll be using the upper limit only because log, if I put t is equal to 0, this will be log 1. Log 1 is equal to 0. So I'll be putting x only. Log 1 plus x divided by x power 2024 upon plus 1 upon the derivative of x square, which is 2x. Okay, so this makes it limit x approaching 0 log 1 plus x whole divided by 2x x raised to power this plus 1. Again, this is of the 0 form. If I put x is equal to 0, log 1 upon 0. Log 1 is 0, so this will be 0 form. I again have to apply this rule. So here now b will be given by, this will be limit x approaching 0, derivative of log 1 plus x will be given by this, and this is first into derivative of second. So you have 2x into 2024 into x power 2023 plus x power 2024 plus 1 into 2. Right. Okay. So now let's put x is equal to 0. So you will get this will be x is equal to 0. This will be 1 and here will be 0. So you will have 2. That will be 1 by 2. So this is your value of b. I got the value for a and b. Now let's pick up this equation. You have 2bx squared plus ax plus 4. Now you are given two equations. I'm picking up the second one, which says 2bx squared plus ax plus 4, and I had a as 1, b as 1 by 2. This will give me x squared plus x plus 4. This is, see, the discriminant here is less than 0. What is discriminant? This is given by b squared minus 4ac. And discriminant, if I see in this part, this is b squared, which is a coefficient of x, 1 minus 4ac, which is 4 into 4, that is minus 15. This is less than 0. That means roots will be imaginary. Discriminant is negative. Root will be imaginary, and you know imaginary root always come in pairs. They don't come in like single things. What will be the root now for this? Let's just discuss. This will be given by minus 1 plus minus 15 iota upon 2. So one root will be minus 1 plus 15 iota upon 2, and the second root will be minus 1 minus 15 iota upon 2. So these roots will be imaginary, and you know imaginary roots, they come in pairs. So that means it is said in the question that they have a common root. No, because this equation is having two roots which are in pair. So that means if one root is common, then both roots will be common to them. So that means these equations, the first one was, let me see the equation. Cx square dx plus e is equal to 0, and we just saw the second equation came out to be this. So they have two common roots. Okay, and that implies this is possible only when both the equations actually they are same. That means these two equations, they are equivalent. Being equivalent, you will have c is equal to 1, d is equal to 1, and e is equal to 4. What you have to find out in the question was DCE ratio. So you have DCE ratio will be 1 is to 1 is to 4. So this is the answer to the question. 1 is to 1 is to 4. Option D. Hope you are clear with this. Let's move to the next question then. Question number 3, the foci of the hyperbola are same that of this ellipse. The centricity of the hyperbola is 15 by 8 times the centricity of the ellipse, and the smaller focal distance of this point on the hyperbola is equal to. So you are given me, I'm given the equation of the ellipse as this. So you have a square as 9. That gives me a is, let's say this is ellipse, right? So I'll say a1. a1 is equal to 3, and b1 square is 25. That gives me b1 is equal to 5. So here the two foci, you are given a hyperbola's foci is same that of the ellipse. So this foci is given by 0 plus minus b1 e1. Now I don't have e1. Let's calculate e1. E1 is given by 1 minus, you have a smaller than b, so I'll be taking a square upon b square. This is equal to root of 1 minus 9 upon 25. On solving, this will give me 4 upon 5. This is your E1. Okay, so now the foci, this becomes that is equal to 0 plus minus 5 into 4 by 5, which is equal to 0 plus minus 4. This is the foci of your ellipse. Now let's talk about the eccentricity of the eccentricity of hyperbola. That is given by Let's say that's E2. And you are given in the question that this is 15 by, where it is, 15 by 8 times the centricity of the ellipse. What was the centricity of the ellipse? It was 4 by 5. So this is equal to 15 by 8 times the centricity of the ellipse. That is equal to 15 by 8 times into 4 by 5. Or this will give me 3 by 2. Eccentricity of the hyperbola is this. And you are given that foci of hyperbola is same as ellipse. Both are having same. So this is given as 0 plus minus B2E2 is equivalent to this. So this makes B2 E2 is equal to 4. E2 was 3 by 2. That's equal to this. So B2 will be equal to 8 upon 3. Right. What I have to find out was focal distance of this point on the hyperbola. So let's start. First of all, what was your E2? E2 is given by, I need to have the A2 value. Okay, I have the B2. I got the E2. I need to find out A2 now. So E2 is given by 1 plus for the hyperbola. You have this value, E2 square, B2 square. Centricity was 3 by 2 is equal to, I'm taking the square over here, 1 plus A2 square, and B2 square is given by this. So it will be 9 upon 4 is equal to 1 plus A2 square divided by into 9 upon 64, or you have 64 plus 9A2 square upon 64 is equal to 9 by 4. This will cancel 16, right? Yeah. So you will have this as, let's do the cross multiplication. 64 plus 9A2 square is equal to 144. 9A2 square, 144 minus this gives me, I think it should be 80. So A2 will be given by A2 square. Let it be this only, 80 upon 9. Now, smaller focal distance. The point given to you, what was that point? It is this point. Let's write down. Smaller focal distance from the point root 2, 14 root 3. This and 0, comma 4 is given by root of, this will be this square, 14 root 3, 14 upon 3, this minus 4 whole square. This will give me root of 2 plus, let's do the subtraction, or what shall I do? Let's open up the brackets. Let's do the subtraction, that will be easier. So you will have 14 by 3 root 2 5 minus 4. So I have done the calculations. They were a bit lengthy. So this is the one. I have opened the brackets and this came out to be. Then on solving this, you get this value and this value. So ultimately we come over here. And now you can check out that this is nothing but the square root. And inside this will be 7 root 2 by 5 minus 8 by 3 whole square. So this is equal to, this distance is equal to 7 root 2 by 5 minus 8 upon 3. This is the right answer to the question. And 7 2 by 5 minus 8 by 3, this falls to be option A. Hope you're clear with this. Let's move to the next question, number 4. If one of the diameters of this circle is a chord of another circle C, whose center is the point of intersection of these two lines, then the radius of the circle C is. Let's plot the figure to understand this. So this figure looks something like this. One of the diameters for this circle is the chord of another circle C. This is the diameter PQ, though it doesn't look like, but this is the diameter of this circle. This is chord for this outer circle. Now, looking at the equation of the circle, you have x square y square minus 10x for y plus 13 is equal to 0. So from here, the center is minus g minus f. That's a half, minus half the coefficient of x, minus half the coefficient of y. This is your center for the first. This is your mm, center. 5 minus 2. Okay. Now, you're having the radius for this. Let's calculate. We got the center. Let's also see the radius. This is given by g square, f square minus c. G square is 25. This is 4 minus 13 will give you, on solving, it will give you 4. Let's find out the center for the another circle. This is 2x, the two equations. This is the point of intersection of 2x plus 3y is equal to 12, and 3x minus 2y is equal to 5. Let's multiply this equation, the first one with the 2, and let's multiply this with 3. You will get 4x 6y is equal to 24. 9x minus 6y is equal to 15, or you have 15x is equal to 40, or your radius comes out to be, sorry, I'm not solving the radius. It is the point of intersection. So this is 39. This is 13x is equal to 39, or x is equal to 3, and the corresponding value of y you will solve and you will get 1. If I fill 4x plus 6y is equal to 24, if I fill x is equal to 3, this becomes y is equal to 2. So the point of center for the second triangle, so for the second circle, this is equal to 3, 2, O dash, right? Now, what we need to find out is the radius of the circle C. Okay, I need to find out this radius of the circle C, that is O dash B. For that, let's first of all find out O dash. What is the point O? We just saw that was 5 minus 2. O dash 3 comma 2. So O dash is given by 5 minus 3 square minus 2 square, which is equal to root of 4 plus 4 square, which is equal to 16, or this is equal to root of 20. Now, radius, let's say R dash, radius of the second circle, is given by, if I say the Pythagoras theorem, this is your radius for the first circle. We calculated that was 4, and O dash we just calculated, that came out to be root 20. Applying the Pythagoras theorem, I will be getting O dash B. So this is your O dash B. This is given by the root of R square and T square, which is equal to 6. So this is the answer to the question, option C. Hope you're clear with this. Let's move to the next question. Question number 5, the area of the region xy such that y square is less than 4x, x less than 4, and this expression is greater than 0 and x is not equal to 3. Is to understand the problem, I need to make the figure, and before that, I need to analyze the statement. First, you are having one curve. You are having actually 4 things. First is y is less than equal to 4x, and then the second one, you have x is less than 4. Then you have x y into x minus 1, x minus 2 divided by x minus 3, x minus 4 is greater than 0. So here 2 cases are arising. First case, that y is greater than 0. In that case, when y is greater than 0, then this expression will be x into x minus 1 into x minus 2 upon x minus 3, x minus 4. This also should be positive. Then only this whole thing will value to be 0 in case y is greater than 0. So that means x will belong to the interval 0 to 1 and 2 to 3. Because x is, according to the question, it is less than 4. So I'll not be taking the 4th thing. Okay, I'll be finishing here. Now, the second case comes when y is less than 0. Then, of course, if y is less than 0, then this expression will always also be less than 0. Because the product, then it will be positive, right? Then this also will be less than 0. That's why the product will make a positive. That is a greater than 0 thing. So, from here, x will belong to the interval 0 to, it will belong to the interval. Okay, it will belong to the interval 1 to 2, 3 to 4. Okay, now let's see how the figure will look like. Something, this is first of all, it's passing through the origin, and this is your line. X is equal to, this is actually over here, this is the area. X is less than 4, and this is the area where your this is the curve y square is less than equal to 4x. So this is the one area, and let's see, you are having x is not equal to 3, fine, and you're having from 0 to 1, 2 to 3. So x from 0 to 1, this is, let's say, 1, this is 2, 3, and 4. So from 0 to 1, this is when y is greater than 0, and 1 to 2 when y is less than 0, 2 to 3 when y is greater than 0. See over here, it's 0 to 1 and 2 to 3 when y is greater than 0, and it is 1 to 2 and 3 to 4 when y is less than 0. So like this, these ones, right? Now we are having everything. Let's find out the area. This is the parabola. This is area under the parabola. Parabola is, what was it? Y square is less than equal to 4. I'll be changing the inequality to equality. So y square is equal to 4x. Y will be equal to 2 root x. One more thing, I'll be taking the area of the parabola because this region, this is similar to this one. So if I encounter the area of this, I'll get this only. And similarly for adding the area of this, I'll get this only. So I'll be taking the area, look over here. I'll be taking the area for this upper portion of the parabola, this portion. Okay, let's do this. Okay, so here we have the required area will be equal to limit 0 to 4 root of x dx, which is x power 1 by 2. So this will be x 2 into x power 3 by 2 divided by 3 by 2 limits this, or you will have 2 into 2 by 3 x power 3 by 2 0 to, sorry, it was 4, not 2. Yeah, it was 4. So you will have 4 by 3. This will give me 4 power 3 by 2, which will be 4 power 3 by 2 minus 0, which will give me 2 power 3 or 80, not 82, 32 into this. Sorry, 8 into this, 32 upon 3. This is the answer, 32 upon 3. We have option D as the right answer. Hope you're clear with this. Let's move to the next question, number 6. It says if fx is equal to 4x plus 3 upon 6x minus 4, and this x is not equal to 2 by 3, f of x is equal to gx. G is a function from for all the real numbers except this, two real numbers except 2 by 3, then g of 4 is equal to. Okay, so where you have fx is equal to 4x plus 3 upon 6x minus 4, and you have a g of x. According to here, g of x is what? F of x. So this will be given by 4 into 4x plus 3, 6x minus 4 plus 3 divided by 6 into 4x plus 3 upon 6x minus 4 minus 4. On solving this, you will get in the numerator, this will be like 16x plus 12 plus 18x minus 12. And this whole thing is divided by 6x minus 4 divided by 24x plus 18 minus 24x plus 16 divided by 6x minus 4. This will cancel with this, and you will have here, on solving this whole thing, you will get 36x upon 34x upon 34, or you will get the x over here. So that means g of x will be equal to x. Therefore, what will be g of g of g of x? This will be x only. And the g of 4, this will be x only, that will be equal to 4. So that's it. You got your answer as option D. Hope you're clear. Question number 7, limit x approaching 0. This whole expression is equal to, and starting from here itself, limit x approaching 0. This is e power 2 sine x minus, let's write it down once, e power 2 sine x minus 2 sine x minus 1 upon x square. This can be written limit x approaching 0, e power 2 sine x minus 2 sine x minus 1 upon, I'll multiply the numerator and denominator by sine x mod square. Okay, so this is limit, now let's say put sine x is equal to t. So as the x approaches 0, t approaches 0. Limits will also change. This limit will be limit t approaching 0, e raised to power 2t minus 2t minus 1 divided by t square into limit, here will be x only, sine square x upon x square. So this is 0 upon 0 form. That means I have to apply L'Hospital rule at this point, taking the differentiating numerator and the denominator. Limit t approaching 0. This will be 2e power 2t minus 2 upon 2t. This is equal to 1 only. So taking the 2 outside, limit t approach. 2 will cancel. No need to take it out. This is e raised to power, no, I have to take it out. Wait. 2t minus 1 upon 2t, because I want the 2t in the denominator. So this is equal to 2 into 1 multiply by 1 again. That's 2. So this is the answer to the question. And this is equal to 2. Option D stands to be the right answer. Hope you're clear with this. Next is the question number 8. If the system of linear equations this has infinitely many solutions, then what is the value for this expression 12 alpha plus 3 beta? So if I write these equations in discriminant form, this is 1 minus 2, 1, 2 alpha and 3, 3 minus 1 and beta. Let's find out the determinant. 1 alpha beta plus 3 plus 2, 2 beta minus 9, 1 minus 2 minus 3 alpha. This is this. Minus 2 minus 3 alpha. This will be alpha beta minus 3 alpha 4 beta, and this will be minus 70. Right. Now for the infinitely many solutions, discriminant should be equal to 0, or actually discriminant should be equal to D1, D2, D3, and all of them should be equal to 0. So first of all, this will be equal to 0. Secondly, if I take D1, so D1 for that, it will be given by minus 4 minus 2. Yes, minus 4 minus 2, and let's check once. Minus 4 minus 2 and 1. Okay. Then it will be 5 alpha and 3. Then will be 3 minus 1 and beta. Let's write it down. So this will be 5 alpha and 3, 3 minus 1 and beta. From here, this will be equal to 0. Let's go for D2. This will be given by 1 minus 4, 1 and 2 and 5 and 3. Then 3, 3 and beta. This will also be equal to 0. So you will have a 5 beta minus 9 plus 4 2 beta minus 9 plus this is equal to 0. This gives me 13 beta minus this, or 13 beta will be equal to 54. Beta will be this. Now let's put this beta in this equation. There it is. Yes, I'll be putting beta in this equation. So let's say that's equation 1. From 1, alpha beta minus 3 alpha 4 beta is equal to 17. So you had um 54 upon 3 alpha minus 3 alpha plus 4 into 54 upon this is equal to 17. 54 alpha minus 39 alpha plus 216 is equal to 221, or on solving this whole you will get 15 alpha is equal to this, or alpha will be equal to 1 by 3. Now what was your beta? Okay, beta is left to be calculated. No, okay, we did beta. It was this. Now you have to find out 12 alpha plus 13 beta. So you have 12 into 1 by 3, 13 into 54 by 13, or you have 4 plus this, and 54 is the right answer. This is the one, option D. Hope you're clear with this. Next is question number 9. The solution curve for the differential equation this, when x and y both are greater than 0 passing through the point E, comma 1 is. Okay, let's write down the differential equation. You have dx upon dy. I'm taking the y on the right hand side. So this will be x upon y, and log x minus log y. I can write it like this. Okay, some quite simplified now. Let's put x upon y is equal to t. That gives me x is equal to t into y. And let's differentiate both sides. Dx. Let's differentiate both sides with the respect to y, right? So this will give me dx upon dy is equal to first function to derivative of second plus second function into derivative of first. Correct? So what will this equation now be? Let's use this equation, merging them. You will get this is equal to t plus y into dt upon dy is equal to x upon y was your t log t plus 1. So this will be, let's open the brackets, y into dt upon dy is equal to t into log t plus t minus t. They will cancel, and you will have this thing. So you will be having dt upon t into log t is equal to 1 upon y into dy. Right. So let's integrate both the sides now. Integrating both the sides, you will get this will be given by, let's put log t is equal to some p. So this will be differentiating both sides with respect to p. This is equal to dp. So now this expression will become, this will be given by integral of dp upon p is equal to dy upon y. Or from here, you will have log p is equal to log y plus c. Taking log on both sides, you will have no, not log. I'll just fill in first of all this. This is log t is equal to log y plus c. Log t was log x upon y. This is equal to log y plus c. Now you're given in the question that the point E1, that means when x is equal to E, you have y as 1. When x is equal to e, y is 1. So let's use this to find the value of c. So you have log of e is equal to log of 1 plus c. This is equal to log of 1 is equal to log of 1. This is 0 only. So c, so that means c is equal to 0. Now this expression, this will be equal to log of x upon y is equal to log of y, or log of x upon y is equal to, this will be given by mod, taking mod over here, and this will be e raised to power log of y, which is equal to y only. That's it. You have the solution. Log x, this is log x upon y is equal to y. So this is the answer to the question, and this option C is the correct answer. Hope you're clear with this. Let's move to the next question. Question number 10 says, let alpha, beta, gamma belongs to the integers A be given by this, B, C, D, with the vertices of the parallelogram A, B, C, D. If AB is equal to root of 10, the points A and C. First of all, let's make the figure. Then only it will be clear. So this is your parallelogram. Let's say the point A, alpha, beta. This is the point B. It's given 1, 0. The point C is gamma and delta, and the point D is 1, 2. Now, if AB is equal to root 10, this is root 10, and the point A and C lie on the line A and C. This is the diagonal. This lies on the line 3y is equal to 2x plus 1. And what is the value for this expression? All right, first of all, let's get to find the midpoint of the diagonals. These are the two diagonals. You know, diagonals they are, sorry, diagonals of a parallelogram bisect each other. Diagonals of parallelogram bisect each other. So that means E is the midpoint on BC. Let's find out the coordinates of E. So E will be given by 1 plus 1 upon 2, 2 plus 0 upon 2, which will be 1, 1. So this is the coordinate 1, 1 E is having. And E is, this is delta, and what is this? Gamma and delta. Okay, so from here, E is midpoint on AC also. So that means 1 is equal to alpha plus gamma upon 2. Also 1 is equal to beta plus delta upon 2. Correct? This gives me this, and beta plus gamma gives me this. What I need to find out is twice into this thing. To find twice alpha, beta, gamma, and delta. So this is 2, and this gives me 2, and this gives me 2. So the answer is 8. This is the answer to the question, option D. Hope you're clear with this. Next is question number 11. Let y is equal to yx be the solution for this differential equation where x belonging to 0 to pi by 2 satisfies this equation. Then what is y of pi by 3? That is when x is equal to pi by 3. What is the value for y? So I'll start from here itself. Dy by dx, I'm using this. Dy by dx is equal to tangent x plus y divided by sine x into secant x minus sine x tangent x. So dy by dx, this is equal to, I'm opening this sine x upon cos x plus y. So let it be like this only, and I'll open the secant also and the tangent also. Okay. Here you have sine x plus y into cos x, sine x into cos x, 1 upon cos x minus sine squared x upon cos x. So this will give me dy by dx is equal to sine x y cos x divided by sine x cos x. This will be 1 minus sine square x in the numerator, which is nothing but cos square x upon cos x. So this and this will cancel, and you will have sine x y cos x divided by this, right? So, okay, this will be given by sine x upon sine x cos square x y into cos x upon sine x into cos square x. This and this will cancel, this and this will cancel. And let's multiply the numerator and denominator by 2. You will have this will be secant square x plus this will be 2 sine x cos x. This will give me, see, this in the numerator you are having 2y upon 2 sine x cos x, which is equal to 2y to sine 2x. So this is equal to 2y into cosec 2x. All right. So this is this thing. This is equal to dy by dx. Hope you're clear with this. So this is of the form dy by dx is equal to p into plus p into y is equal to q. So here the integrating factor will be e power p dx, which is equal to e power. I'll be using this cosecant minus because it will be moving on this side, right? Minus cosecant 2 is also taken outside, 2 cosecant 2x dx. Let's say 2x is equal to t. So 2 dx upon dt is equal to 1, or dx is equal to dt upon 2. So now what will be your this e raised to power? It was minus 2 cosecant 2x cosecant 2x dx. This will be equal to e raised to power minus cosecant. This will be log of tangent. Wait, I'll put first of all, right? This will be equal to e power minus 2 cosecant t, and dx is given by this. So this 2 and 2 will cancel. This will be e raised to power minus cosec t dt. This is equal to e power minus log of tangent of t by 2, right? So this is equal to, what is t? E raised to power this tangent t was 2x, so this will be tangent x, and this will be e raised to power log of 1 upon tangent x, right? Because this minus will move as the power of this, so it will come in the denominator. I'm rewriting this a bit clear like this. So this will be equal to nothing but 1 upon tangent of x. So now the equation will be y into integrating factor is equal to integral of q into integrating factor into dx plus c. So this will be y into 1 upon tan x. This will go like this, is equal to integral of secant square. Q was equal to your secant square into integrating factor, which is this. See, your q was a secant square over here. This I have taken as q and this was taken as p. Okay, so this multiply dx plus c. So y into 1 upon 10x is equal to, this will be equal to, it will cancel, and this will be, let's put one thing, tangent of x is equal to this. So secant square of x will be dx will be equal to dt. So this will be 1 upon this into dt plus c, and this is log of t plus c. So y will be equal to mod of tangent x log of, let's put, this was log of t is tangent x only plus c, right? Now you're given in the question that y pi by 4 is equal to 2. That means when x is equal to pi by 4, y is equal to 2. So here x is pi by 4, and for that y is equal to 2. This is equal to tangent pi by 4 log of tangent of pi by 4 plus c. 2 is equal to 1 into this. So this will be c only. That comes the value of c. So now this expression will be equal to y is equal to tangent x log of tangent x plus 2. What you had to find out was the y of pi by 3. So this gives me y is equal to tangent pi by 3 log of tangent pi by 3 plus 2. Right? So root 3 log of root 3 plus 2. This is the answer to the question, root 3 log of root 3 plus 2. Natural log. So option A is the right answer. Hope you're clear with this. Let's move to the next question. Question number 12, let A be this vector. Question number 12, let A be this vector, B be this vector, and C be this vector, be the three vectors. If A vectors B satisfies this equation, and the dot product of P and A is equal to 0, then the dot product of these two vectors, that is P and this vector, is equal to. So note down these three vectors. I'll be using them. First of all, let's pick up this one. The P cross B vector, this is equal to B cross C. C cross B vector. That means P cross P minus this is equal to 0. So this can be written as P vector minus C vector cross B vector is equal to 0. So P vector minus C vector is equal to lambda V vector. This makes P vector is equal to C plus lambda V. Also, you are given that the dot product of B and A vector is equal to 0. So P, okay, this can be written like this: C dot A plus lambda A dot B is equal to 0, right? I have filled like P vector over here, right? So now further this C dot A, what was your three vectors? Let's write down the vectors first, or I'll be picking up from here itself. Okay, so let's solve here. This is your C and this is your A vector. Let's find out the dot product of them. 3 into 1. Then you have minus 3 into 1. This will give me minus 3. Then 4 into minus 2. This will give me minus 8 plus lambda into A dot B. So this is 12 plus 1 minus 14. 12 plus 1 minus 14. This is equal to 0. This gives me solving minus 8. And this will be minus 1 is equal to lambda. Minus 1 lambda is equal to 0. So lambda comes out to be minus 8. P vector is equal to this. If I use this equation 1 from equation 1. P vector is equal to C minus 8P vector. So P vector, what was your C vector equal to? I minus 3J plus 4K. I minus 3J plus 4K minus 8. What was your B factor? 4I J 7K. 4i, j, and 7k. Let's check everything was positive. Yes. All right. So this is 1 minus 32. This will be equal to minus 31i minus 11j minus 52k. So I got the p vector. Now we had to find the dot product of p vector with I minus j minus k. So minus 31i minus 11j minus 52k dot product I, j, and k. This is equal to minus 31, 11, and 52, which will give you 32. Okay. So this is the answer to the question 32. That is your option D. Hope you're clear with this. Next is question number 13. The sum of this series is equal to up to 10 terms. You have to find out the sum of the series. See, this sequence, if I see the sequence, the general term will be given by, this is 1, 2, 3. So this is R upon TR is equal to R whole thing divided by 1 minus 3R square plus R power 4. This is your general term. So this can be written as like this, R power 4 minus, let's split the middle term, 2R square minus R square plus 1. If I pick up this thing, see, I'm using this, and this. This is what? R square minus 1 whole square minus this. So this is first and this is the second term. This will be given by a plus b into a minus b, R square minus R minus 1 and R square plus R minus 1. This is your TR. I'll do one thing. Let's try to make these factors which are in the denominator somewhat in the numerator as well. So I can write it like this, R square plus R minus 1 minus R square minus R minus 1. I have already this R, and let's divide by 2 outside. See, this will be R square will cancel. 2R will be there. To compensate that 2, I have divided with 2. R was already there, and 1 plus 1, it will also get cancelled, right? R square minus R minus 1, R square plus R minus 1. So this is equal to half into, let's divide. You will have 1 upon R square minus R minus 1, 1 upon R square plus R minus 1. So now it's been quite simplified. Sum of 10 terms. This was your general term. TR, sum of 10 terms will be equal to I is equal to 1 till 10 TI. Or you can say R for your, because we have been using R. That will be better. Okay, so this will be given by 1 upon this. This will give me minus 1 and here also minus 1 for the first term. And plus this will be, when I put R is equal to 2, this will be 1 upon 4 minus, let's solve it here. Okay, let's write it down. 1 upon 4 minus 3 minus 1 upon 4 plus 1, right? Okay, plus third term, this will be 1 upon third term, like 9 minus, this will be 4 and minus 1 upon 9 plus 2. Okay, so on it will go on till the last one. When n is R is equal to 10, this will be 1 upon 100 minus 11 minus 1 upon 100 plus 9. That will be 109. Okay, so this is the one. Let's simplify it. You have 1 by 2 outside. This will be, I'm just writing it as such, minus 1 plus 1 minus 1 by 5 plus 1 by 5 minus 1 by 11 so on. This will be 1 upon 89 minus 109. Okay, so this will be equal to 1 by 2. This will cancel with this will cancel with this. Similarly, all the terms will cancel. Ultimately, you will be left with this and this term. 1 minus 1 minus 1 upon 109. This will be minus, I'm taking outside, 110 upon this, or this will be minus 55 upon 109. So this is the answer to the question. We have D option as the correct answer. Hope you're clear with this. Next is question number 14. Question number 14, the distance of the point Q from the line passing through P and perpendicular to the lines R, and where lambda belongs to real numbers, and this line where mu belongs to real numbers is equal to. See, a vector in the direction of the required line can be a vector in the direction of the required line can be obtained by the cross product. So it will be given by I, J, and K. This will be 2, 3, 5. And minus 1, 3, 2. So this on solving, it will give me, you will solve this whole thing. I 6 minus of 11, no, 15. And minus J 4 plus 5 plus K multiply 6 minus plus 3. So this will give me minus 9I minus 9J and plus 9K. This can be written as, I'm taking minus 9 common, I plus J minus K. All right. So now the required line will be given by required line will be. See, it is passing through this point, 5 minus 4, 3. So the required line will be given by 5I minus 4J plus 3K plus lambda dash, let's say this is minus 9I J minus K. So this will be, can be written as 5I minus 4J 3K minus 9 into lambda. I'll write it lambda dash. Let's write it as another variable, which is lambda, like this. Okay. Now, let's say this is your point A, 0, 2, minus 2. And this falls perpendicularly on this line, this particular line at the point P. I have to find out the distance AP. Okay. Now the position vector of the P is equal to 5 plus lambda I, lambda minus 4J plus 3 minus lambda K. So for AP, this will be given, I'll be considering the A also. This will be 5 plus lambda minus 0, I, 6, 4 minus lambda minus 2. This will be lambda minus 6J. Then 3 minus lambda plus 2. This will be this K. All right. So the dot product of AP with I, J, and K is equal to 0. Let's multiply. This will be 5 plus lambda, lambda minus 6, 5 minus lambda, minus 5 minus lambda. Minus 5 plus lambda is equal to 0. This gives me lambda is equal to 2. So I got the point P as well. See, when I got the lambda is equal to 2, what will be the point P? From here, P point will be lambda was 2. So this will be 7 minus 2 and 1. So A point already was 0, 2 minus 2. And the P point came out to be 7 minus 2, 1. You have to find out AP. This is root of 7 minus 0 square plus 2 minus 2 plus 2 square, which is equal to 4. And this will be equal to 9. So you have 49 plus 16 plus 9, which gives you a total of root of 74. So this is the answer to the question. Here you have the option as the correct answer. Hope you're clear with this. Let's move to the next question, number 15. For alpha, beta, gamma, if sine inverse alpha plus sine inverse beta plus sine inverse gamma is equal to pi, and alpha plus beta plus gamma multiply alpha minus gamma plus beta is equal to 3 alpha beta, then gamma is equal to. Let's say sine inverse alpha is equal to A. That gives you alpha is equal to sine A, sine inverse beta is equal to B, sine inverse gamma is equal to C. So you have beta as sine B and gamma as sine C. And you're having, they are not equal to 0. They are equal to pi. So that means your A plus B plus C is equal to pi, because their sum was equal to pi. Sine alpha plus sine beta plus sine gamma is equal to y. So that means A plus B plus C is equal to pi. And what else? Let's write it here. A plus B plus C is equal to pi. And from here you have alpha beta gamma, alpha beta minus gamma is equal to 3 alpha beta, which gives me alpha plus beta square minus gamma square is equal to 3 this, or you have alpha square beta square plus 2 alpha beta minus 3 alpha beta minus gamma square is equal to 0. Alpha square beta square minus gamma square minus alpha beta is equal to 0. Or you have alpha square plus beta square minus gamma square is equal to alpha into beta, or this will be, it can be written like this, alpha beta upon, I'll be multiplying both the sides by 2. Now this is what? This is your cos C is equal to 1 by 2, which is your cos 60 degree. So your cos C is equal to pi by 3. Sine C will be equal to root of 1 minus cos square C, which is equal to 1 minus cos square C is this, which is root 3 by 2. And what I had to find out was gamma. Gamma is equal to sine C, which is equal to root 3 by 2. That makes the option A to be the right answer. Hope you're clear with this. Next is question number 16. It says two marbles are drawn in succession from a box containing 10 red, 30 white, 20 blue, 15 orange. These marbles with replacement being made after each drawing. Then probability that the first drawn marble is red and the second drawn marble is white is. Actually, this is pretty easy question because you are having 10 red, 30 white, 20 blue, and 15 orange balls. How many total are there? 75 balls total are there. So probability that the first ball drawn is red. How many red balls are there? 10. So this is the probability that first ball is red and the second one is white, because it is with the replacement, so number of balls will not change. Now it will remain the same. And how many red balls are there? Sorry, white balls are there? 30. So 75. Simple as that. So this is equal to cancellations again. This will 2, this will be 25, this will go at 6 and 25 again. So you have yeah, 25. Oh, sorry, this is 15, not 25. And this will be 2 and 5. So you have 4 upon 75 as the answer. Simple as that. Very easy question indeed. Option D is the right answer. Hope you are clear. Next is question Question number 17, let gx be the linear function and fx be given by this. This is equal to gx when x is less than equal to 0 and this function when x is greater than 0. This is continuous at x is equal to 0. F dash of 1 is equal to f of minus 1. Then the value of g3 is you need to calculate. So let's say g is ax plus b function. Now you are given that fx is continuous at x is equal to 0. So that means, for the continuous, you have the left hand limit is equal to f of 0 is equal to the right hand limit. Let's go for this limit x approaching 0 plus. That's the right hand limit. For 0 plus, I'll be taking this function. This will be 1 plus x upon 2 plus x raised to power 1 by x. This will give me 1 by 2 this, or this will be 1 by 2 raised to power infinity, which actually is equal to 0. Let's go for left hand limit. This was your right hand limit, and you are given that this is equal to gx, and gx we assumed to be ax plus b, so this is equal to b. Now you are given that the function is continuous. That means the left hand limit is equal to the right hand limit, which makes b is equal to 0. Now your fx was equal to 1 plus x upon 2 plus x raised to power this. So taking log on both sides, log of fx is equal to 1 by x. This can be written as log 1 plus x minus log of 2 plus x. This is equal to, let's differentiate both sides. This will be equal to 1 upon fx into f dash x is equal to, you will have the denominator square first thing, denominator into derivative of the numerator, this, minus log of, I will write it like this one. Okay. Now, you are given that f dash of 1 is equal to f of minus 1. So first of all, let's go for finding f dash 1, right? This will be equal to, I'll be taking this on the right hand side. So this will be f of 1 into 1 upon 1, this 1 minus 3 minus log of this was 1, 2 upon 3. Yeah, whole divided by 1 square. So this is 1 only, right? So f dash 1 is equal to f of 1. That is what I don't know. I will leave it as such. This was being multiplied. So this will be 1 minus 2 minus 1 minus 3. This will be 1 minus 6. And minus log of 2 by 3. Let's find out f of 1 also. You are having fx is equal to greater than 0. This is the function. 1 plus x, 2 plus x power 1 by x. F of 1 will be equal to 2 by 3 power this. So f of 1 will be equal to 2 by 3. Let's say this is equation 1. Now this is given that this is equal to f dash 1 is equal to f of minus 1. Let's calculate f of minus 1 also. This will be equal to, because we are taking the negative value, right? See, for less than this, you are taking the value, you have to take out the value of gx. Gx we assume to be ax plus b. So this will be given by a into minus 1 plus b, which is equal to minus a. B was already 0. So this is equal to minus a. So f of minus 1 is equal to minus a. Let's say this is 2. This was your f dash of 1. Now you're given in the question that f dash 1 is equal to f of minus 1. That means both of them are equal. That means minus a is equal to 2 by 3, 1 by 6 minus log of this. Okay, so you will have minus A, as this will be 1 by 9, 2 by 3, log 2 by 3, or A will be this minus this. So your gx function, that was ax plus b, which was equal to 0. So that was only ax, and the a is calculated to be this. Right, this is your gx. Now what you had to find out was g3 in the question. So G3 will be 2 by 3 log of 2 by 3 minus this, multiply this. This will be 2 log 2 by 3 minus 1 by 3. This will be taken square. So this will be 4 by 9 minus 1 by 3. So this is the answer to the question, log 4 by 9 minus 1 by 3. This is not there, but okay, that means it needs some more solution or more calculation will be needed. Let's get back. This was your G3. So this is equal to, I am having some E powers. This can be written as log of E power, log of here, E power 1 by 3. This is equal to log of 4 by 9 into 1 upon E power 1 by 3, or this is equal to log of this. Let's write it properly. So this is the answer to the question, divided by. All right. 4 by 9. This, that makes you have option. Wait, yeah. Not the A. Option D as the right answer. Hope you're clear with this. Next. Question number 18, let fx be given by this matrix for all x belonging to real numbers, then 2f of 0 plus f dash 0 is equal to. So first thing, f of 0, let's find it over here only. This will be 0, 2, 0, and then it is this 104, 1, 6, minus 2. If you'll find out determinant, this will turn out to be minus 1, minus 4, plus 0 plus 1. This will be 8. So this will be 12. Let's find out the f dash x. This will be given by 3x square, 4x, 3, and 6x, 2, 3x square, 2x. No, sorry, I will be taking one at a time. Okay, so this will be written as 3x squared plus 2, 2x, x cube plus 6, x cube minus x, and here will be 4, here will be x squared minus 2 plus. Now I'll be taking the derivative of the second row. First will be written as such, x cube 2x squared plus 1, 1 plus 3x, 6x, 2, 3x square. X cube minus x, 4x square minus 2 plus. Then now you will have x cube 2x square plus 1, 1 plus 3x. Here will be 3x square plus 2, 2x, x cube plus 6. Then you have 3x square, 0 and 2x. All right, like this. This is the determinant again. So now let's find out f dash of 0. The matrix will be 0, 0, 3, 2, 0, 6, and 0, 4, and minus 2. Plus, this will 0, 0, 0. This will be 1, 2, and 4, 1, 0, 2, minus 2. Plus 0, 1, and this is 1, 2, 0, 6, minus 1. Wait a minute, this will be, this was x cube, right? Like this, minus 1. So, and here was 0 and 0. Let's solve. This will give me 3, into this will be 8, right? Plus these are like 0, 0, 0. So this will be 0 only, minus, no, this is plus only. So plus this will be 1 into 0 minus 0. This was minus 1 into this, plus 1 into 0. Is this plus 6. Wait, I'll redo a bit of. Okay, so this will give me 0, and here was your plus. This is plus. Now you are having minus 1, and this will be minus 6, minus 0. So this is, yes, 1. My, what is this? Minus 1. Okay, so 2, this, and minus of minus, this will be plus 6, right? Plus 1 into 0 minus 0. This is 24 minus 6. That gives me 18. So you have f of 0 as 12 and f dash 0 as 18. Right? What do you have to find out? 2f0 plus this. So 24 plus this, which is equal to 42. So this is the answer to the question, option C. Hope you're clear with this. Let's move. Question number 19. 3 rotten apples are accidentally mixed with 15 good apples, assuming that the random variable x to be the number of rotten apples in a draw of 2 apples, the variance of x is. Here you are having 2 bad apples, 3 bad apples, and 15 good apples. That gives you a total of 18 apples. And let's say x be the variable for number of bad apples drawn. So let's make this chart. Let's say this is your variable x, and this is probability of x. No bad apple, 1 bad apple, 2 bad apple. For probability x, no bad apple is drawn. That means you are withdrawing all the good apples, 15C2 divided by 18C2. This will give me 15 into 14 upon 18 into 17 into 2. I hope like you can solve this. This will give you 35 upon 51. And you have bx1, 1 good and 1 bad apple. This will be given by on solving. This will be 15 upon 51. Probability that you choose 2 bad apples. So you are having 3C2 upon 18C2, which will give you 1 upon 51. So this is 15 upon this, 1 upon this. Correct? Now, EX, it will be given by 0 into this, 1 into this, plus 2 into this. This will be 0 into 35 upon 51, 1 into 15 upon 51, 2 into 1 upon 51. This will give me 1 by 3, right? This is your E of x. Now the variance is given by summation E x square minus E x whole square. Now Ex square, this will be equal to 0 into, it was your 35 upon 51, right? Plus 1 into 15 upon 51 minus 2 square into 1 upon 51. Here was supposed to be 1 square, and I don't need to write 0 square anyways. So this is equal to 1 minus 3 whole square. This will be equal to 15 upon this, and plus 4 upon this minus 1 upon this. This will be 19 upon 51 minus 1 by 9. So this will give me, let's take the LCM, 51 and 9, 3. You have 17 and 3. So 17 nines are, you have 153. Yes. So this is 153, and on solving this, you will get 40 upon 153. So this is the answer to the question, 40 upon 153. Option D is the correct answer. Hope you're clear with this. Let's move to the next question. But question number 20, let S be the set of positive integral values of A for which this expression is less than 0 for all x belonging to the real numbers. See the denominator, if I look at it, x square minus 8 plus 32, the discriminant of this, you have b square minus 4ac. Discriminant is given by b square minus 4ac, that is 4 into 32. That's 128. This is a negative value. That means this is always gonna be positive. That means numerator will be negative, which is ax square plus 2 into a plus 1 into x plus 9a plus 4. For this term to be negative, this is possible only when a and discriminant, both of them, the discriminant and the a will be negative, then only this term will come out to be negative. There's no other chance. And you are given that S is a set of positive integral values of a. Positive integral values, a is less than 0, they contradict each other. A is less than 0, this is a negative set of negative values. And here you are asked S is the set of positive integral values. That means nothing such exists. Value of S is a null set. So this contains 0 elements. Option B is the right answer. Hope you are clear with this. Let's move to the next question, number 20. Question number 21, if the integral 525 limit 0 to pi by 2 integral sine 2x cos power 11 by 2x into this expression dx is equal to this. You have to find out the value of n. So let's say this is equal to I. I'll start from here itself. So you're given this, let's write it properly once. I is equal to 525 integral 0 to pi by 2 sine 2x. I'm opening this. I will write it as 2 sine x cos x power 11 by 2. Then, okay, cos x power 11 by 2. Then you have, here is one x over here. Let's check. No, there is no special x. This is just a multiplication. 1 plus cos power 5 by 2x whole raised to power 1 by 2 into dx. So this is equal to 5 to 5 limits 0 to pi by 2. Let's take this outside 2. And you will have sine x cos x. This will be, I'm adding both of them, cos 11 by 2 plus 1. This will be 13 by 2 power 13 by 2 x. And this will be 1 plus cos power 5 by 2 x raised to power 1 by 2 dx. Now let's put 1 plus this is equal to t. You will have 5 by 2 cos 5 by 2 minus 1 x into derivative of cos x, which is minus sine x dx is equal to dt. So now this integral will be equal to 525 into 2. This is equal to 1050. Limits will also change. When you are having x is equal to 0, then t will be equal to 2, and when you are having x is equal to pi by 2, t will be equal to 1. So the limits will be from 2 to 1. And over here, what will be, this is equal to cos power 5 by 2 minus 1. This is equal to cos power 3 by 2. So this will be, solve this one a bit over here. I'll wait. Okay. Now I'm get back to this one. 5 by 2 cos part this into sine x dx is equal to dt. Here when x is equal to 0, t will be equal to 2. When x is equal to pi by 2, t will be equal to 1. So here dx will be equal to dt upon minus, I'll be writing over here 2 into 5 into sin x will come in the denominator, and this will be cos part 3 by 2x. Okay. So let's come back to our integral now. This will be equal to 1050. Limits will be now 2 to 1. Minus 5 by 2 minus, this will be 2 by 5. So into minus 2 by 5. I'll take it outside. And this will be, what was that? Okay. So let's write it as sine x into cos 13 by 12 2x into this is equal to t power 1 by 2 multiply by dx is equal to 1 upon dx is equal to minus dt into that I have taken care of, and here will be sine x into cos part 3 by 2x into dt has already been written. Okay, so now this will be minus 420 limits 2 to 1. Sin x will cancel from here, and cos 13 by 2 minus 3 by 2. This will be cos bar 10 by 2, which is 5x into t power 1 by 2 into dt. So cos x, cos power 5x into, let's write it, minus 420. See, cos power 5x, we have taken over here, I have taken 1 plus cos power 5 by 2x is equal to t. So cos power 5 by 2x is equal to t minus 1, or squaring both sides, cos power x will be equal to t minus 1 whole square. So this will be equal to t minus 1 whole square into root of t into dt. Let's open this. Minus 420 integral limits were 2 to, what were the limits? 2 to 1. Okay. Limits 2 to 1. This will be t square into this. This will be t power 3 by 2. And then plus root of t minus t minus 2t. So this will be minus 2. This was supposed to be 5 by 2. And this is this into dt. And I'm changing the limits. This will be 420 and 1 to 2 limits. This is t power 7 by 2 into 2 by 7 minus 2 into t power 5 by 2 into this plus t power 3 by 2 into this. This is, I have just opened the integrals. Solve the integrals. So this will be 420. Let's put the limits. Let's check with one's everything. Yes. Okay. Now this will be root 2. I'll be taking outside. And here will be 16 by 7, 16 by 5, 4 by 3, minus 2 by 7, 4 by 5, plus 2 by 3. Actually, I have just, you have to fill in the limits. I have solved the sum previously and done all the calculations. So ultimately, you will be receiving this. You just need to do the calculation part. No worries in that. Okay. So this will give you 176 root 2 minus 64, which was equivalent with your given one, n root 2 minus 64. So you have n as 176. Okay. I hope I don't need to do this calculations. This is your limit, upper limit minus lower limit. You have to fill in the limits and you will get your answer. Okay. So that's it. The answer to the question is 176. There is no option. This is just your answer. Hope you're clear with this. Let's move to the next question, number 22. It says let S be equal to -1 to infinity and f a function from S to the real numbers be defined as fx is equal to this. Let P be the sum of square values of x where fx attains local maximum on S and Q is the sum of the values of x where fx attains local minima on S, then the value of P squared plus 2Q is equal to. So here you are given the function fx is equal to integral -1 to x e power t minus 1 raised to power 11 to t minus 1 raised to power 5 t minus 2 raised to power 7 t minus 3 raised to power 12 2 t minus 10 raised to power 61 dt. Let's differentiate both sides. You will have f dash x is equal to e raised to power, I'm filling the limits, e power x minus 1, 2 into x minus 1 raised to power 5, x minus 2 raised to power 7, x minus 3 raised to power 12, 2x minus 10 raised to power 61. When you will fill in for like -1, this will be 0. This, let's solve this. This will be 0. The first one, 1 minute. Yeah, this will be 0 and this will be 2 minus 1 power 5. Then this will be, okay, this will be 0. So this ultimately be, everything will be 0. I don't need to write it. -0. Right? This is f dash x. So the point of extremes, let's see over here. You're having the breakpoints as 0 first, 1, then 1 by 2, then you have 2, then you have 3, and then you have 5. So within this, from 0 to this side, this will be positive, negative, positive, negative, negative, and then positive. So that means the loop maxima is 0 and 2, and minima is 1 by 2 to 5. Therefore, P is the sum of the values of x where fx attains a local minima on S, and Q is the sum of values of x where fx attains a local minima on S. So that means your P is equal to 0 plus 2 square, which is 4, and Q is equal to 1 by 2 plus 5, which is equal to this. So you have to find out P square plus 2Q. This is 4 square, 16 plus 2 into 11 by 2. That is equal to 27. So this is the answer to the question 27. Hope you're clear with this. Let's move to the next question, number 2. Question number 23, the total number of words with or without meaning that can be formed out of the words from the word distribution taken 4 alphabets at a time is equal to. So you have the word distribution, DISTRIBUTION. This is the word distribution. Here I is repeating itself 3 times and the T word alphabet it's repeating itself 2 times. The rest of the words alphabets DSRBUON, they are coming once only. So these are 7 alphabets. This is 3 and this is 2. Let's count this as one group only, and let's count this as the second group. Okay, so first case, when all distinct alphabets are used. See, this is 7, this is 8 and 9, right? So from these 9 alphabets, let's consider this as one set and this as the second set. So one will be picked up from here. Maybe one may be picked up from here and the second may be picked up from here or anyone from this. So this is 7, 8, 9. And 9C, you have to pick up 4. And those 4, they can be arranged in 4 factorial ways. All right. This on solving will give you 3024. Now the second case, when 2 alike and 2 different alphabets are chosen. So when 2 alike, so that means 2C1. There are two alphabets that are like I and T multiplied by, and the remaining will be from 9. You'll be left with 8 sets now. So from that, you'll be choosing 2 again. And that can be arranged in 4 factorial ways, and that has been repeating. So divided by 2 factorial. This will give me 672. Next, 2 alike plus 2 another alike. So this will be given by 2C2 into 4 factorial upon 2 factorial into 2 factorial. Because here you will be picking up 2C2, and from the rest of also, from here, from the first group you will be picking up, and from the second group you will be picking up, divided by, they can be arranged, multiplied by, they can be arranged in 4 factorial ways, divided by, they are repeating, so 2 into 2. This is being divided, that's equal to 6. Now the last, you are having 3 alike and 1 different. So you have 1 different, 1C1, 3 alike, so 1C1, and it will be 8C1. So this is multiplied by 4 divided by 3 factorial. This is equal to 32. Now the total words will be, that is 3024, 672, and 6 and 32, which gives me 3734 as the total. So this is the answer to the question, 3734. Hope you're clear with this. Let's move to the next question. Question number 24, let Q and R be the feet of the perpendiculars from this point on this line and this line, respectively. If QPR is right angle, then what is the value for 12A square equal to? So here you have the point P. This is having the coordinates triple A. And let's say this is the point Q. This falling perpendicularly on this line. Longer. So this is the line. And let's say this is the point Q. This line is given by x is equal to y. So let's say that x upon 1 is equal to y upon 1. X upon 1 is equal to y upon 1, and z is equal to 1. So this gives me z minus 1 upon 0, right? So this is the line, and the second one line, again, the coordinate this, and in this case, let this be the point R. And here the coordinates, this line is given by x is equal to minus y. So this will be given by x upon 1 is equal to y upon minus 1. This is z is equal to minus 1. So this will be z plus 1 upon 0. Now here the PQ vector, this will be given by, let's say the coordinates of this are x and y are equal. So I'll take this as lambda, lambda, and 1. And let's say the coordinates of R, they are t, and minus 1. Correct. Now the PQ vector, you are given that this point P falls perpendicularly on this line, which means the PQ vector is perpendicular to this vector. So that means the dot product of PQ with, over here you are having I plus J. This is equal to 0, and similarly here you are having PR vector with the dot product of I minus J is equal to 0. P is given by AI plus AJ plus AK, and here you will have this is lambda, lambda, lambda. This is AAA, so this will be lambda minus A plus lambda minus A. This is equal to 0. This gives you 2 lambda minus A is equal to 0, or you will have lambda is equal to A. So you will have the coordinates of Q as A, and 1. And let's find out the coordinates of R. Similarly, here you will have T minus A minus T minus T minus A. This is equal to 0. This gives me T is equal to 0, because 2t will be equal to 0. So this gives me t is equal to 0. That means the coordinates of R will be equal to 0, 0, and minus 1. Now it's given that QPR, this is a right angled triangle, right angle. So this is Q, this is P, and this is R. So it must be something like this. This is Q, This is P and here is your R. This is right angle triangle. So that means again, what will happen? Their dot product, that is the dot product of PQ and PR will be equal to 0. PQ dot PR. This will be equal to 0 because these two lines, these two vectors, they are perpendicular to each other. We already had Q as this and R as this. Let's say what is PQ. This will be given by P was this AA and Q was AA1. That was, let's write it over here. Your P was having the coordinates AAA and the Q had the coordinates as AA1. So this PQ vector will be given by, this will be, see this A will cancel. You will have here 1 minus A, I cap, K cap, because this is 1 minus A. And similarly, you had P as A, and the R point as 0, 0, minus 1. So PR vector will be given by minus 1. No, this will be PR vector will be given by minus A I cap minus A J cap minus 1 plus A K cap. Right. So their dot product is 0. Let's write down this over here. You had 1 minus A K cap. The dot product of A with minus AJ minus 1 plus A K cap. This is equal to 0. That makes 1 minus A into 1 plus A. This is equal to 0. This gives me A square. 1 square minus A square is equal to 0 or A square is equal to 1. What you had to find out was 12A square. So 12A square is given as 12. That's it. You got the answer. 12 is the right answer to the question. Hope you're clear with this. Let's move to the next question then. Question number 25. In the expansion of 1 plus x into 1 minus x square, into this expression where x is not equal to 0, the sum of coefficient of x cube and x power minus 13 is equal to. Let's write down the expression. You are given, let's say this is ex, this is equal to 1 plus x. I'm breaking down 1 minus x as 1 plus x into 1 minus x. And this can be written as, I'll write it first of all like this only. 1 plus 3 by x, 3 by x square, 1 upon x power 3 whole power 5. So this is equal to 1 plus x into 1 minus x. I'll take 1 power 1 upon x power 3 power 5 common from here. So this will be this and this will be reduced to 1 plus 3x plus 3x square plus x cube. Right. So I'm starting it from here, right? 1 plus 3x square plus 3x cube whole power 5. That was, so this is equal to 1 upon x power 15. This will be 1 plus x, 1 minus x, 1 plus x. This will be equal to, this is the power of, this is nothing but, let's solve it over here. 1 plus x cube. This is equal to a cube plus b cube plus 3ab into this. This will give you this expression only. So this is 1 plus x whole power 3 power 5. This is equal to 1 upon x power 15, 1 plus x, 1 minus x, 1 plus x, 1 plus x power 15. Now this will be reduced to 1 upon this. This is 1 minus x into 1 plus x, 1, 2, and 15. This will give me x power 17, right? And let's do this thing. I'm opening this bracket. You will have 1 plus x power 17 upon x power 15 minus x, okay, this thing. So this x will be utilized over here. I'll be writing it x power 14 in this case. Now, let's get back to our question. What do we have to find out? The sum of the coefficient of x cube and x power minus 13. So what is the coefficient of x cube? This term will not have any coefficient of x cube because the maximum power of x in this case will be 17 and the denominator is having this. So the maximum power this expression can have for the x is 2. And if I look at over here, this is the maximum power of x which can this term have, and this is the maximum power of n x in the denominator. So you can have one x cube. So the coefficient, if I talk about of x cube in the given expression ex, this is equal to 0 from here, minus of 1 will be the coefficient from here, this is equal to -1. Similarly, coefficient of x power -13 in this expression, this is given by 17c2 minus 17c1. 17c2, this one solving will give you 136 minus this, so this is 119. What do you have to find out? The sum of, let's say this 1 and this 2, sum of these coefficients, which is -1 plus this, that's 118. So this is the answer to the question 118. Hope you got that. Next is question number 26. It says if alpha denotes the number of solutions for this expression is equal to 2x and beta is equal to this, where z is this complex number multiplied by this, where I is equal to minus iota, then the distance of the point AB from this line is, here you are given that 1 minus iota power x, this modulus. So mod of this thing is equal to root of 1 square plus minus 1 square, which is equal to root of 2. So that means you have root 2 power x is equal to 2 power x. This gives you this is possible only when x is equal to 0. So that means if alpha denotes the number of solutions, that means alpha is equal to 0 over here. Now let's get back to our complex number. You had the complex number z is equal to pi by 4, 1 plus iota power 4. This is 1 minus root of pi iota upon pi plus iota plus root pi minus iota 1 plus root pi iota. Iota is equal to root of -1. You know this. This is imaginary root. So let's take the LCM. This will be this multiply. Let's check I have written right. Yes. So this is a square plus b square, which is pi only. And plus similarly over here, a square plus b square. See, you had 1 minus pi iota into 1 plus pi iota. This is a square plus b square. Iota square is equal to -1. So this gives me 1 plus iota, and here, sorry, 1 plus pi and pi plus 1 over here. Okay. Now denominator, let's multiply both of them. This will be root of pi plus iota plus pi iota plus root of pi iota square. Okay, so now this will be equal to pi by 4, 1 plus iota power 4. This will be 2 taking common, 1 plus pi whole divided by, see, iota square is equal to -1. So these two will cancel out and I'll be taking iota common, 1 plus pi outside. These two will also cancel and this will be equal to pi by 4, 1 plus iota power 4 into 2 upon I. Or I can write it like this. This 2 and 2 will cancel, and iota, let's multiply the numerator and the denominator by iota. Denominator will have iota squared, that is equal to, you know one thing, iota square is equal to -1. This has been used a number of times in this question. I hope you know this thing, so I have not told you. Okay, anyways, so here you are having iota square. This makes expression as pi by 2, 1 plus iota power 4 into iota. So let's open this now. This was your z. So z is equal to minus pi by 2 iota. Let's open this. You are having 1 plus iota square, whole square. This will be equal to minus pi by 2 iota 1 a square plus b square, which is iota square, plus 2 iota power 2. Iota square is equal to -1. This will cancel and you will have minus pi by 2 iota, and this will be 4 iota square only, which is -4. Iota square is equal to -4. This minus sign will be cancelled, and this 2 will cancel this. You will have 2 pi iota. This is your complex number after the simplification. Now this is your z. Let's find out what your beta was. Beta was given as the modulus of z divided by the argument of the complex number. Modulus of the z will be equal to 2 pi square, which is equal to 2 pi. And the argument is given by pi by 2 over here, looking at this. So this is divided by pi by 2. That gives you 4. This is your beta. What you need to find out is distance of the point alpha and beta. Alpha we calculated 0, beta we calculated 4 from this line. So the given point is distance of this point from the given line, which is 4x minus 3y minus 7 is equal to 0. This will be given by 4 into 0 minus 3 into 4 minus 7 divided by root of 4 square plus 3 square. This is equal to, this will be, this is not, alpha is not equal to 1, alpha is equal to, alpha is not equal to 0, alpha is equal to 1 because x is equal to 0 is a solution. So this point will be 1 and this will be 1. So 4 minus 12 minus this will give me modulus of this. So the answer is 3 because the distance can't be negative. So 3 units, this is the answer to the question. Hope you're clear with this. Let's move to the next question. Question number 27, let the foci and the length of the latest rectum of this ellipse where a is greater than b be given by this and root 50 respectively. Then the square of the centricity of this hyperbola is equal to. So you have to find out the centricity of the hyperbola and from where, like, I don't know the a and b in this case. Where are a and b? I will get the a and b from the ellipse. Okay. So the foci for the ellipse is given to you. We are talking about the ellipse in the first case. The foci for the ellipse is given to you plus minus 5. And what else? The latest rectum you're given. Root 50. What is the formula for latest rectum for the ellipse? 2b square upon a. And the foci is given by plus minus AE comma 0, which is equivalent to this. This makes AE is equal to 5. And from here you have a 2b square is equal to, I'll take, this will be 5 root 2, right? Yeah. 5 root 2 into a. And this will cancel root 2. You will have a b square is equal to 5 upon root 2 into a. Okay. All right. So I have the b square. I have a into e. No, one thing that b square is equal to a square into 1 minus e square for the ellipse. And this b square is equal to this. Correct? So let's solve it further. I also have the value for AE is that's equal to this. So this makes a square minus AE whole square is equal to 5 root 2 into a. AE is equal to 5. So this makes AE minus 25 is equal to 5 root 2 upon into a. Let's do one thing. Now it's becoming a quadratic, right? Let's multiply all the sides by root 2. Root 2a square minus 25 root 2 minus 5a is equal to 0. Or you will have a root 2a square minus 5a minus this is equal to 0. Okay, this is equal to 0. That's in the A. Let's solve. See, one thing now I was wondering, I need to find out the eccentricity of this hyperbola. Okay, fine. I will get the A now. Okay, so A will be given by, will be root 2a square minus 10a plus 5a minus 25 root 2 is equal to 0. Or you have root 2a common from here, a minus 5 root 2. Yeah, plus 5 will be taken common, a minus 5 root 2. So the two factors for a can be equal to 5 root 2 or it can be minus 5 upon root 2, right? Me see root 2a plus 5 is equal to 0. Yes. So these are the two possible values for a. And let's check the value for a. E was equal to 5. So this makes e is equal to 5 upon a. So I'll be taking the value of a as this positive. I can take any of the value because a can have the two values, 5 root 2 and minus 5 upon root 2. To decide like which value should I take for, I will consider b square. B square is equal to 5 by root 2a. So the two possible values, that means I'll solve it here. B square was equal to 5 by root 2a. So there are two possible values for a. If I take the first one, a is equal to 5 root 2, then b square will be equal to, it will be 25. Right? And if I take a is equal to minus 5 upon root 2, then b square will be equal to minus 25 by 4, which is not possible. Square cannot be negative, so I will not take this value for a. I'll be taking 5 into root 2 only. Okay, I got the value for b square over here. This is equal to 25, or b came out to be 5. I got the value for a. I got the value for b. So what is the value for e now? This will give me e is equal to this, or e is equal to 1 by root 2. So let's write down now for the ellipse what we got. A is 5 root 2, B is 5, eccentricity is 1 by root 2. Now, what is your equation of the hyperbola? This, let's make the equation of the hyperbola. Given hyperbola. So your given hyperbola was equal to x squared upon b squared minus y squared upon this is equal to 1. X squared, b squared is 25 minus y squared. A squared is 25 into 2, that is 50. And b square, do I need to solve it? Anyways, this is a square is 50 and b square is 25. So this makes it quite a number, 1250. This is equal to 1. And the eccentricity will be given by, this will be a square plus 1 upon a square plus 1 upon, wait, for the hyperbola, it will be given by like this, a square, b square. This is equal to b square into e square minus 1. Let's say e1, because this is the centricity of the hyperbola now. Okay. All right. So this is equal to 1250, and this is equal to 25. This is e1 square minus 1. This makes it 25. This is equal to 50. Right. So 51 is eccentricity of the hyperbola. Square of the eccentricity of the hyperbola is equal to 51. So this is the answer to the question. Hope you're clear with this. Let's move to the next question, number 28. Question number 28, let A and B be the two vectors such that the magnitude of A vector is 1, B vector is 4, and the dot product of A and B is equal to 2. C is equal to this vector. If the angle between B and C is alpha, then 192 sine square alpha is equal to. Okay, so one thing you are given over here is this, if this is equal to minus 3b. So let's write it down. You are having C vector is 2a cross b minus 3b vector. Let's do the dot product of this with b. This will be equal to 2a cross b dot b minus 3b square. And the dot product of B and C, this is equal to BC into cos alpha. This is equal to, this will give me 0. So this is minus 3B square. The magnitude of B, it's 4. And I'm not given the magnitude for C. No. Okay. So this is 4 into, let's write it down, C only, cos alpha. This is equal to minus 3B square. That is equal to 16. That is equal to minus 48. So you will have a C into cos of angle between B and C. This is equal to minus 12, correct? Now, I hope this is clear till here. Also, you are given that the dot product of A and B is equal to 2. So that means the magnitude of A into magnitude of B into cos of angle between them, A and B. Let's say that is some angle theta is equal to 2. A's magnitude is given 1 and B is having the magnitude of 4. So this is equal to 4 into cos theta is equal to 2. This gives me cos theta is equal to 1 by 2. So that means over here the theta value will be given by pi by 3. So now let's see over here. You were given this. Let's once again pick it up. you have the C vector square is equal to 2A cross B magnitude minus 3 this square, this magnitude whole square. So this is equal to, we just calculated 2A minus 2A cross B magnitude. This will be given by, this is equal to the magnitude of 2. 2 will be taken outside, 2A and cross B. So this is equal to sine of angle between them minus 3. B is 4. This is the magnitude square. So this is equal to 2A. 2 is this, not will be outside. A is 1 and this is equal to 4. This is equal to root 3 by 2 and 2 over here. So this will be minus 12 whole square. And this will give me 64 into 3 by 2 plus, see the magnitude this square plus minus of 12 whole square. This is 144. This on solving will give you 192. Now let's get back to our this equation. You had this mod of C into cos alpha is equal to minus 12. So you already have, this was equal to mod of C square. You already have mod C into cos alpha is equal to minus 12. And you have this thing. So let's squaring on both the sides. You will have mod C square into cos square alpha is equal to 144. This is equal to 192. We just solve. Cos square alpha is equal to 144. You have cos square alpha is 144 upon this, or 192. What in the question was 192 sine square alpha. I need to have a sine square alpha. So this can be written as 1 minus sine square alpha is equal to this, or you will have sine square alpha is equal to 1 minus this. It will give me 192 minus 144, 844, 80, 48 is upon 192, or 192 sine square alpha is equal to 48. So this is the answer to the question 48. Hope you're clear with this. Let's move to the next question. Question number 29, let A be this set, B, R be this set of ordered pairs, be a relation on A. Let S be the equivalence relation on A such that R is a subset of S and the number of elements in S is N. Then the minimum value of N is, you're having the set A containing the elements. This R contains 1, 2, 2, 3, and 1, 4 ordered pairs. Now, let S be the equivalence function on A such that R is a subset of S. So you are given S is equivalence for R subset of S, and that means reflexive number of elements in S is N. Okay, we'll talk about that later. For S belonging to S and reflexive, you will have 1, 1, 2, 2, 3, 3, and 4, 4. And for symmetric, it will be 2, 1, 4, 1, and 3, 2. For transitive, 1, 3, 3, 1, 4, 2, and 2, 4. Now the S will be equal to, if I combine 1, 1, 2, 2, 3, 3, 4, 4, 1, 2, 2, 1, 1, 2, 2, 3, 1, 4, 4, 3, 3, 4, 2, 1, 4, 1, this 1, 3, 3, 1, 4, 2, 2, 4. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So the number of elements is equal to 16. Number of elements is equal to 16, and this is the answer to the question. Hope you're clear with this. So let's move to the last question of the paper, question number 30. Let f be the function from real to real numbers be the function defined by fx is equal to this, and m is given by this function, n is given by this when a is not equal to 2. If alpha into m is equal to beta into n for alpha and beta belonging to the natural numbers, then the least value for alpha squared plus beta squared is equal to. Here, if you check the limits, this is f of a and f of 1 minus a, and the f function is given by this. Fx is equal to 4 power x upon 4 power x upon 2. And what will be f of 1 minus x? That will be this 4 power this plus 2. Right? So let's do adding both of them. You will get fx plus this is equal to 4 power x upon 4 power x plus 2, and I'll break it up. This will be given by 4 into 4 power, see, I'll solve it here, 4 into 4 power minus x upon 4 into 4 power minus x plus 2, and this will be given by 4 upon 4 power x, and this will be 4 upon 4 power x plus 2. The denominator is this, and this will cancel after taking the LCM. Okay, so this will be equal to 4 upon 4 into 2 into 4 power x. Hope you are clear with this. Okay, so I will write it as 4 upon 4 plus 2 into 4 power x. Or this will be, what is this? 4 power x. I'll take one thing. This is 4 power x upon 4 power x plus 2 plus 4. I'll be taking 2 common from here. This is 4 power x plus 2. So let's again take 1 upon 4 power x plus 2 common from here. This will be 4 power x upon 1 plus 2, or this will be equal to 1 upon 4 power x by 2. This will be 4 power x. Okay, this is nothing. Okay, fine. This is only 3. So you will have 1 as the answer for this. Now, your m function, let's pick it up. M function, this was limits f of a to this x sine power 4 x into this function. So as x approaches f of a plus this minus x, this is equal to nothing. That was your 1 minus x. So m will be equal to f of integrals limits f of a 1 minus a. Now I can write this x because if I add both of them, I will get 1 minus x. And you know by the King's rule, what was the King's rule? Limit, if you're having two variables, let's say g and f as the this integral limits, f x dx, this can be written as limits g to f of g plus, okay, I can't take f over here. Let's take anything else, h variable. Let's have g plus h minus x dh. So that is what I'm doing. F of a plus f of minus a, that is equal to 1 minus x. So this can be written as 1 minus x minus this x. Okay. 1 minus x, yeah. So, sorry, into sine power this, and that's again will be changed into 1 minus x, and 1 minus x, this will be 1 minus of minus x, this will be equal to x only. So this thing dx. All right. And yes, what was your n function? This is equal to sine power 4x into this. All right, let's open this. This is limits f of a to f of 1 minus a sine power 4 x into 1 minus x dx minus integral f of a f of 1 minus a x into sine power 4 x into 1 minus x dx. And now look at the question. This is your n and this is your m. So and this was already your m. This function that we were calculating, this was your n. This is n, this is m, and we already are solving for this is equal to m. So now the equation becomes m is equal to this, or you have 2m is equal to n, or m upon n ratio 1 by 2. And now this is alpha m beta n. We had 2m is equal to n. So this gives me equivalent to this. This gives me alpha as 2, beta as 1. What is alpha square plus beta square? This will be 4 plus 1. That's 5. This is the answer to the question. So students, with that, we have completed all the 30 questions for the paper and hope you are clear with them. Don't forget to visit our website, www.examsnet.com, and do download our app. The link is available in the description box, because on our website you will find all the entrance exam question papers with the detailed PDF solutions, and our app is a very good place for you to explore everything at an easy pace. So students, best of luck, keep shining, keep rising high. That's all for this paper, and don't forget to watch our rest of the videos for rest of the JEE Mains 2024 papers. Students, that's all for this paper. Very best of luck. Bye.